Okay, I'm good to go. My name is Emmanuel Stapf. I work for Eiffel software. I've been around for 12 years. I was part of the team who developed Eiffel for .NET back in 1999-2000. Basically, Eiffel has been standardized via the ECMA organization back in 2005. We had also an ISO standard back in 2006. And what I'm going to describe today is available in the current version of Eiffel Studio. What I'm going to talk about today is one of the fundamental aspects of the basic object-oriented operations, which are method calls, or also we say it in Eiffel feature calls. The idea is that when you have such an instruction x.f of args, it's basically the semantics is to apply the feature f with the given arguments to an object which is represented by x. So basically what I'm going to talk about today is how do we guarantee that x will always be attached to an object at runtime. And because if it's not attached, then you have most likely some kind of exception mechanism that will be triggered. One of the issues in programming is the aspect of null. So null means that it's not you have a variable which is not attached to an object. Null is still a very sound concept. It's very useful for representing a linked list. So it's not easy to get rid of null from any language. So it's a good abstraction, and we have to keep it. So one of the success stories of static type checking is that we allow x.f.args if we can guarantee at runtime that if there is an object attached to x, and if it has a feature f, then we can call f. So and all is done through type checking. So basically, assignment to x are only allowed if y is the type of y conforms to the static type of x. What does it? So if we try to take that principle and move it to what we call void safety, meaning avoiding a null reference exception at runtime, what we want to do is that the compiler is going to tell you if the call you are doing is valid or not. So how do we do that? Basically, whatever solution is adopted should follow some kind of guidelines. So I'm listing a little bit of the guidelines we have. So it has to be statically and completely void safe. It has to handle genericity. It should be simple for programmers without any mysterious rules. It should be easy to teach, reasonably simple for compilers, implementers, and should be compatible with existing code. Some of the ideas of the proposed solution is that we have the notion of some patterns that you can, when you look at your code, you know that for sure it's never going to be a failure. The target object x is always attached. You can also improve the type system by having the notion of attached types and detachable types. We need a set of rules to ensure the initialization of variables, and we have a special case for arrays. So basically, the only validity rule that we have added to the language is the target validity rule that says that x.f of args is permitted only if the target x is attached. That's very simple. What does it mean? Basically, attached is a static property, and we say x is attached is whether if either the type of x is attached, or if in the context where you look at x, it's guaranteed by the compiler to be attached. So let's give an example. If you look at the following line of code, can we guarantee that it's void safe? Actually, we can't, because if x is any kind of expression, it might return different values if you call it twice in a row. So let's assume that x is a variable. Will it work? Not completely, especially if you have other instruction that might assign to exp. and resetting the value. So one of the basic rules that we can have in this pattern is that we considered exp to be attached if it's a local variable or a formal argument of the routine. We can't do it for general expression or for attributes because of the other instructions part. So we have this notion of what we call the certified attachment pattern. It's more like a code flow analysis, but a little bit standardized so that every compiler can actually implement the same code flow analysis, so that you have a program that runs the same way on various compilers. And so the one for local variable, which we describe here, is that if in this block you have no assignment to x, except the last instruction, you can consider that within the whole blocks, x is always attached. So another way to is a different cap, which basically is used for loop. The until block is an exit condition, and therefore, if x is void on entry, okay, we don't do anything. So if we go into the loop, we know that x was not void, and therefore we can perform calls. Here another more complex example for a linked list. And we have a various set of caps in the standard. And basically, what we try is they have to be simple, easy to understand, and of course correct. The way it works with the standard committee is that people can submit their caps and we approve them. And then they also have to be clearly defined so that we can actually implement them in the compiler. Now, caps don't work all the time. So sometimes you have something which is too complex to express. So we have something called the object test. The object test is basically this expression highlighted in green, which is a Boolean expression, which will yield true if the expression exp is of type T at runtime. And if it's the case, it also assigns x to the value of exp. And consequently, in the block below, x is a read-only variable which is attached. And therefore, you can perform calls on x, and the compiler will knows that it's safe to do so because of the object test. So we have the notion of scope, which is important for object tests. So basically, you can see that the scope of the object test highlighted in green is the body of the if statement. So here's a more detailed explanation of the object test. Here, another example where you can use an object test in a condition on the exit condition of a loop. So the next, So one of the goals that we have also is to, if you were to protect all calls with an object test, your existing code will look very messy and heavy. So another thing that we are trying to do is to make the code looks nice. And the goal is to use object test only when it's necessary. So that's why we have the notion of attached types, basically, which are guaranteed to be always, the entities of that type are always attached. And we have detachable types, which basically represent types as you know them today in most object-oriented languages. But if you have an attached types, one of the issues is how you are going to initialize it. So we have the basic normal rules for that. We have basic types are initialized to 0. Expanded types, which are value types in C#, have a special way to be created. And references are always initialized to void, which doesn't work for attached type. You don't want them to be attached to void. You want them to be attached to an object. So we have given rules for, let's say, an attribute. An attribute is attached if every creation procedure, that is to say constructors in C#, are setting them. If you don't set them, then the compiler will trigger an error, and it's going to be a compilation error. A local variable is much easier because it's normal flow analysis. So if it's set before access, then it's considered to be a valid type. Here's a more complex rules about what it means to be properly set. Then one thing, I'm going to skip this and go to the final. It has to work with genericity as well, so I'll skip this. And one of the issue with arrays is that it's sparse representation, and therefore if you allocate an array of 100 elements at runtime, all of them are null or void. So to avoid that, we have equipped array. I mean, here is the way you would create it until today. And basically now, when the type is attached, then you have to use a different creation procedure by providing a default value to all the elements of the array. So this is like the extreme case. In practice, all data structure, like hash tables or arrayed lists that are implemented using arrays, don't use this routine at all. You can be smart about it, and that's what we have implemented. And that's pretty much it. So if you have any question, just now, that's a good time. Otherwise, you can look at those URLs where you can find interesting resources about what I just talked about. Yes?
Do you have any idea how many kind of bugs you prevented by this, or how well this works?
So the question was, how many bugs did we prevent by doing this? So we have basically not completely finalized the conversion of existing code to be void safe. We basically done about, I'll say 30 to 50% of the code Eiffel software provides to users. And we found some bugs, not that many actually. The reason is because we have contracts in Eiffel, and we had a lot of assertion that read something like, my argument cannot be void. And now it translates into removing the contract and put the attached keyword to say this is an attached type, and therefore I can only receive attached expressions. And so we found some. We've listed a little bit on dev.eiffel.com. They are not critical bugs, definitely. They are just minor foresight, I would say. Any other questions? Yeah, in the back?
How do you deal with, let's say, a C# calling into Eiffel and then not having the concept of attached?
So the question is, how do we deal with C# calling to Eiffel and vice versa? So at the moment, we have the notion of boundaries between void safe code and non-void safe code. And when you cross the boundaries, we have to do the check. So actually, we haven't done much work on the C# to Eiffel callback because there is some more work to be done. But the way around, because that's the way we develop for .NET, is that all .NET types are considered to be detachable. And it's a little bit challenging to program in that mode, but at the end, your code is very bulletproof. The other good thing about this void safety mechanism is that what we have realized is that very often code was written under the assumption that something was not void, and you realize that your assumption were not correct. The compiler just highlighted you that this line was not, it didn't have enough context to say that's going to work. And it's actually pretty highlighting as a programmer to see that, because you were not 100% bulletproof. Any other question? Yeah?
Does this impact unit testing at all, when you want to pass nulls around when you don't care about stuff a lot of places? So
does it affect unit testing? I assume you mean like more automatic unit testing, or?
Well, so often when you're unit testing something, you want to pass nulls or voids around.
Yes. So
you don't care about.
So in that case, the unit test you wrote will be rejected by the compiler, because if the routine you are calling accept only attached types, you can't pass void or null. So it will tell you at compile time when you compile the unit test. If it's more dynamic, then there is still some gray area in this area. But this is more, Eiffel is not really a dynamic language, so when you look at the, within Eiffel, everything is bulletproof. It's whenever you interact with the external world via .NET or via other means, that's where we have to protect those entries to make sure that the external world is not going to do bad thing to the Eiffel program. Does it make sense?
I can just see that the syntax you've got would kind of encourage you to potentially protect larger, or conservatively protect larger blocks than you actually need to avoid having to have tests around every single access to an object. And if you do that, you'll potentially reduce the number of situations where you can pass a null as a parameter in the unit test for in situations where it's actually valid for you to pass null because you're not actually testing, although production code may need some non-null version for whatever it's doing. In your unit test case, you can go, okay, for this particular test I can pass null, but because of the extra syntax checking, the compiler won't let me pass null, so it could potentially reduce the number of unit tests that you might be able to run.
Yeah, and and Eiffel is all about that because we have contracts, and actually contracts are a great tool to reduce the number of unit tests. And they are actually very good to also augment the other aspect, which is automatic testing, because contract gives you some information about that. And any other questions? Okay, thank you very much, and let's go to lunch, I guess.